So we're going to continue with our previous lesson and being able to prove that triangles are congruent by using the congruency postulates and theorems. We started, if we jump down here, yesterday we did side, side, side. We said that if three sides of one triangle were congruent to three sides of another triangle, then you could say that those two triangles are exactly the same size. We said that side, angle, side, if I have one side congruent, and the included angle, that's the important part, the included angle. If that was true, then those triangles are congruent, as opposed to if I had two triangles that are congruent, or not two triangles that are congruent, but if I had two triangles where your two sides were congruent, but you have your angle is not included. This one doesn't work, right? That was SSA and it doesn't work. We're not allowed to use that. Look at the difference between where the angle is here versus where the angle is here. And it's just the ones that we label. That's all we care about is the sides and the angle that we label. We don't care about the rest of them. We also talked about how the HL is the only get around. It's the only one that goes around the SSA rule. It allows us to break it when I have two sides and an angle, but the angle is a right angle. Notice it's hanging off the end like this SSA. But when that happens, we can use HL. It only works when we have right triangles because right triangles are the only time that we have a hypotenuse. And we're going to add two more for 5 total. These are two angles and a side, okay? And where the side is, just like with side, angle, side, where the angle was mattered. In this case, where the side is matters. So really pay close attention to where the side is in this case. So the theorem says that if two angles in the included side, included means it's in between. If two angles in the included side of one triangle are congruent to two angles in the included side of a second triangle, then the two triangles are congruent. Here's what we've got going on. I have that angle B is congruent to angle D. I have that angle C is congruent to angle F. And I have that AC is congruent to DF. Look at how this is labeled, okay? I have an angle marked, I have an angle marked, and I have a side marked. That side connects those two angles together. Since it connects those two angles together, the side is in between. It's in between the two angles. Then this is the angle side angle theorem. Look at where the S is. It is included. The S is included in the name, just like it is included in the picture. Versus, look at this one. Look at where these are. I have the angle. I have the angle. So I have angle A matches with angle, corresponds to angle D and is congruent. I have angle C is congruent to angle F. And I have BC, side BC is congruent to EF. Look at the difference between these two. Only look at the colored pieces. Look at how like these angles are sitting on top of, or they're holding on to that line. But this one, only C. Right? In this case up here, I have angle A, I have angle C, and I have side AC. Look at the letters, right? Now look here. I have angle A, I have angle C, just like I did before, but look, I have side BC. Look at the difference between that. Angle A, angle C, side AC. That is included in its angle side angle. This one is angle A, angle C, and side BC. Okay, BC doesn't attach to the A and the C. It only attaches to one of them. Okay, that is angle, angle, side. See, what you can do is look at it. See, this side has A and C just like it has that. So the side, think about it like this, is attached to both of the angles. Whereas in this case, the BC is only attached to the C. So the side is only attached to one of the angles. The other angle is left off. You really have to pay attention to what is included. So this one is the angles are the angle is non-included, or the side is not included in between the two angles. Again, there are 3 sides and 3 angles of every triangle, but we are only talking about the ones that are colored. Now, yesterday we had a side, side, side. Well, what happens if you have an angle, angle, angle? Let's look. So in this case, I gave every student in the room 3 angle measurements, and I said, draw me a triangle that has an 80-degree angle, a 60-degree angle, and a 40-degree angle, and look at what I got. Everybody gave me a different size triangle. Now you can see these are all 40-degree angles, these are all 60-degree angles, and these are all 80-degree angles. But they change, right? I could have an angle that's really big like this, or I can have this angle that's really small like this. But they're the same size, right? If this is a 60-degree angle, this is also a 60-degree angle. It's just the sides of it are longer. And that's why angle, angle, angle will show that they're the same shape, or they are similar to each other. They are proportional, but it will not show that they are the same size. Okay, so angle, angle, angle will never prove that I have triangles that are the same size. It only proves that they are the same shape. Okay, so we have, here are our 5. Side, 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 angle, side, HL as a replacement to SSA, ASA where the side is included. Here's my side, here's my angles on either side, and then angle, angle, side. Here's my angle, here's my angle, and here's my side. Only look at the colored pieces, which is why it is so important for you to mark the pieces with color, because it will help you to see what happens. So let's look at some practice problems with this. Okay, decide whether the triangles are congruent. Again, for them to be congruent, they have to pass side, 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 angle, side, HL, angle, angle, side, or angle, side, angle. They have to pass one of those 5 that we just looked at on the table. So let's look and see what we have. So I have angle N is congruent to angle H. I have KN is congruent to GH. And I have angle K is congruent to angle N, or excuse me, angle K is congruent to angle G. If you are having trouble deciding, notice I have 2 angles and a side. So here are my only options. 2 angles and a side. My 2 choices are angle, angle, side, or angle, side, angle. The question is the side included? If you are having trouble deciding this, write down your pieces. Angle K, angle N, and side KN. If your 2 angles are both your ends of your segment, then it is included. KN includes N and K. Okay, so those are included. So this, yes, the triangles are congruent. They are congruent by angle, side, angle. The side is included between these 2 right here. And G, B, H, here's G, here's B, here's H. It goes from 2 to no marks to 1 mark, is congruent to K, P, N. Okay, always start with the pieces that you know. Let's look at number 2. So PM is congruent to ST. I'm just going to mark one triangle. PM is congruent to ST. Angle P is congruent to angle S. And then I look, that's all the markings that I have. However, I know, because of the geometry that I know and the vocabulary that I know that those 2 angles, P and M, is congruent to S and T. So I'm going to color one side of that. Those are congruent to each other. So I notice I have 2 angles and a side marked. As soon as you have 3 pieces, you can stop. I have 2 angles and a side. So the question is it angle, side, angle, or angle, angle, side? We'll look and see. And again, if you're having a hard time telling, write them down. Okay, we'll just call it N, since we're just going to use this one triangle. That makes it easier to see. Angle N, angle P, and angle PM. Notice that both of these angles are not included in this segment. So we're going to use the not included one, right? This is the one where the side gets left out. So it is, yes, they're congruent by angle, angle, side. And MNP is congruent to TNS. Okay? Number 3, label the pieces that you know. I know that QRP is congruent to TRP. I know that QPR is congruent to angle TPR. And then that's all the markings, but I have to go by the other things that I know, right? Those things that we summarized yesterday, your vertical angles, your alternate interior things from parallel lines, or your reflexive property. Okay, don't forget this side is congruent to itself. RP is congruent to RP. So we have angle R, we have angle P, and we have side RP. 2 angles, 1 side. That means yes. The question is it angle side angle or is it angle angle side? I have Q, I have R, and I have P, and I have side RP. That means it's included, so that would be angle side angle. Then you want your congruency statement, so PQR, P to Q to R, notice the markings, 2 to none to 1. So we'll go in the same order, P to T to R, P, T, R. Okay. Now in this case, we're going to go with just what we have marked first because there are lots of things that can happen in number 4, but we're going to just start with our basics and what we have marked. I have that this angle here at A, angle DAB, is congruent to angle DCE. Oop, don't want to mark it over there. I only want to mark on one triangle, sorry, it's habit. Okay, then I have that ABD is congruent to CED, so I'm going to mark this one too. And then I have that AB marked is congruent to CE marked. Now, since I have 3 pieces marked, there are other things I can mark. I could mark it here that this is congruent to this. My vertical angles are congruent, but because I have 3 things marked, I'm going to stop. Okay? I don't need any more because there are actually 2 optional answers on this one. It could be angle, angle, side, or angle, side, angle. But based on what I have right here, this is angle, side, angle because the side is in the middle. Angle A, angle B, and side AB. So yes, these 2 triangles are congruent because of angle, side, angle. The side is in between, so I put the S in between. So A, B, D is congruent to C, E, D. A, B, D, 1, 2, none, 1, 2, none. So that's how you name it. So in that case, you have options, and it is true. This is true, right? We know that those vertical angles are congruent. So at that point, I could say, I could prove that they're congruent by angle, angle, side also. But we want to go with our straight up, or most straightforward information when at all possible. Okay, then number 5. Let's look at our markings. I have angle A is congruent, or this angle is congruent to this angle. I have this angle is congruent to this angle, and I have this angle is congruent to this angle. So the question is, are those 2 triangles congruent? Well, I have 3 angles, and I know that angle, angle, angle does not work, right? We said angle, angle, angle does not work. So the answer is no. Those triangles are not congruent, and there is no congruency statement because they're not congruent to each other. There's no guarantee that those 2 are congruent to each other. Now, let's look at things from a different perspective. Let's see if I want to, so that we can kind of get some practice with recognizing our pieces. If I want to say that something is congruent by a particular theorem. So I want to use the angle, angle, side theorem. Okay, so let's look at what I know right now. I know that AC is congruent to AC. I know that the reflexive property says that AC is congruent to AC. I know because these two lines are parallel to each other, this is my transversal, I know automatically that BAC is congruent to ACD. Okay, so I also know that this angle is congruent. Okay, so right now I have a side and I have an angle, and that angle is touching that side. Now I want to use the angle side theorem. I have the side and I have the angle that's touching it. This angle right here is touching that side. There's literally purple on purple, right? So I have the angle that's touching the side. So what I want is the other angle that's not touching. So look at this triangle. You have A and you have D. Those are your choices. Well, A is on the other end. It's touching. A would be touching that purple line. So I have to use D. So D would be my non-touching so that my side will not be included. So I would need to know, in order to be able to use angle side theorem, it's information I don't have that I would need. I would need to know that angle D would be congruent to, we got to go out here over here and find that same piece. I would need to know that angle D is congruent to angle B. If I knew that, then I could say that those two triangles are congruent by the angle side theorem. Okay? So when you're asking for what other piece of information do you need, you have to look at what you have, you have to look at the method you want to use, and then you have to decide where's the other piece of information that I want. So first, again, we always start with what we already have. I already know that P is congruent to R. That's all that we have marked. That's it. Now, what else do we know that is inherent to the problem? I know that PQS is congruent to RQT because those angles are vertical angles. You notice that every time I always say, what do we know and why do we know it? That's because that's what a proof is. So we are doing informal proofs right here. Next week, we're going to write it down. Okay, so there we know that those two angles are congruent to each other. Now, that is it. That's all we've got. We have nothing else that we know. There are no reflexive sides. There are no alternate interior angles. There are nothing because we don't have any parallel lines. We don't have anything. I want angle side angle. I have two angles. I have these two angles. Since I want to use angle side angle, I need the side that is in between, that is attached to both of these angles. So I have, if I just look at this angle right here, the triangle right here, I have P, I have Q, and I want my side to be included between them, which means my side needs to be PQ. So what I need to happen is I need for, here's where you got to be careful, find that same piece, find the corresponding piece on the other triangle. Well, this is marked with 1 and this is marked with 2, so we're going to find the same piece over here. That would be QR. So I would need for PQ to equal QR in order to use angle side angle. PQ is congruent to QR. Those are the pieces that I would need if I wanted to use angle side angle. Okay? Now, I want to use side angle side, so let's look and see what we have first to see what we need. I have that this is a right angle, and I know that all right angles are congruent. I also know, since the one on the right is a right angle, then the one on the left is a right angle also, because they're a linear pair. So that's it. That's all the information that I have. Now this one gets a little more complicated because of that altitude, but we don't have quite enough information, so let's keep going. I know that this piece is the reflexive property, right? That is the reflexive property. It's congruent to itself because it's shared by both sides. So at this point, I have one side and one angle. One side and one angle. Now because I want to use the side angle side, I want my angle to be in between. So if I call this S so that I have it, right? I have my side is SV and I have my angle is V. So for that angle to be included, my other side has to have a V in it. So I'm going to go with this one right here, right? Because it needs to have that VT so that they're included. That V is included in between all of them. So in order for these two triangles to be congruent by side, angle, side, I would also need the information that VT, segment VT, is congruent to segment RV. If I knew that, I could prove those two triangles are congruent by side, angle, side. So in summary, the theorems that prove that triangles are congruent are side, 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 angle, side, hypotenuse leg, which is my replacement for side, side, angle, angle, side, angle, and angle, angle, side. And the two that don't work, I cannot use side, side, angle, where the angle is not included, and I cannot use angle, angle, angle. These are yes. Yes, 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 yes. These are no. Okay, these prove triangles are congruent. These do not. There is no guarantee that they are congruent. If you have those measurements, you would need more information to use it.